Go through the vocab. According to the blank, a product is zero only if one or more of its factors is zero. Alright, that would be, that's number 2, we skipped 1. That is the zero product property. Alright, and remember that's what we use to solve for those quadratics that, let me move this over, that solve for that. This is, when we say our answer is positive 4 and negative 5, that is the zero product property. Alright, and it's because we know that one of them, if just one of them is 0, it doesn't matter what the other parenthesis is, it's because their product is going to be ultimately 0, no matter what. Alright, number 3 is the vertex form. Because of the parentheses with the square on the outside, we have an h and a k. Remember, on the inside of the parentheses, it's got to be negative for it to move to the right. Alright, and it's got to be positive to move to the left. Alright, the A can be problematic because that tells you the squeeze or the stretch or the squeeze, and so sometimes you have to solve for that. We'll get into that later. So that's vertex form. Number 4, that little piece that's part of the quadratic formula, that's under the radical, which means it's called the radicand. That b squared minus 4ac is the discriminant. So I'm just going to actually abbreviate these for speed. 5 is a number with both real and imaginary parts together. It's called a complex number. Number 6, the blank of a quadratic function is the standard form is actually that way, where there are no parentheses and you have an a, b, and c. In vertex form you have an a, h, and a k. Alright, so that's just going to be abbreviated standard form. And then 7 is, ask you to skip it because we actually don't use the completing the square method. That is actually for more pre-calc level students, so we just kind of skip that because it's no need. You don't have to do it unless you're working with conic sections, but that's another thing. Alright, so we're going to go ahead and move on then to number 8. Number 8 was actually kind of another descriptive thing here where you are just describing the transformation of the parent function. Now the parent function, remember, is just x squared, so it's going to be a u shape right there at the origin, and she always goes, she zeros, oh, can't see my paper. Then she goes 1, 1, 1, 1 to the right and left, and then she goes 2, 4, 2, 4. Alright, that's her. That is the parent function. What do we do to her? That is the transformation. And so here you can see that we're actually moving to the left. Our number 8 is left 2, and we're going down 4 based on what we see. That is a movement to the left, and that is a drop of 4. Okay. Over here we have a negative 2 in front. That was not the case here. If it's just a 1, that means that she's going to keep her shape. She's just going to rigidly move up or down, right or left. But if that A is different than positive 1, then we know that it actually kind of compresses or stretches. Alright? And so for 9, what we would say is that not only does it move to the right 1, not only does it go up 5, okay, given by the h and the k, but the negative 2 means that it's going to go downwards, okay, and it's going to squeeze in towards its axis of symmetry, okay. So it would look like this. It's not going to go down 1, 1, it's going to go down 1, 2, okay. So she would basically, there's all kinds of adjectives you could use. You could say stretch towards the y-axis, you could say, or axis of symmetry, you could say squeezed, you could say stretched vertically, tighten. I used to use the word tighten all the time. So yeah, so that's that. Alright, so now we're moving to 10. Number 10 is identify the vertex, axis of symmetry, maximum or min, domain, and range of each function. Okay, so for that we're going to have to understand how to graph these very clearly. And so 10 says that I have g of x equals negative, okay, so it's going to be pointing downward. I have an x plus 3 squared, so it's going to go to the left 3, and then a plus 2. Alright, so let's get all of these descriptions for that. It's going to be moving to the left 3 and up 2. Okay, so left 3, up 2. Okay, so here's our origin. And then we're going to be pointing downwards because of the negative sign. Alright, now once I get a good graph here, 2, 4, 2, 4, I can get all of the other labels. Okay, so the vertex is this guy right here. That is going to be -3, +2. We've got the axis of symmetry. Okay, the axis of symmetry is always x equals something because it is the spine. Okay, so if you know the vertex, it's always just going to be the x coordinate. Okay, so x equals -3 is the axis of symmetry. Is maximum or min? Well, the vertex is going to be a maximum because he's at its highest point. So this guy's a max. Okay. What else? Domain. Okay, the domain for quadratics, it's always real numbers. Okay, it's always, unless it's a piecewise function, the domain of a quadratic will always stretch all the way from -infinity to +infinity. So if you wrote it like this, that's just as good. Okay. All right. Now for the range, though, for quadratics, you're going to have a max or a min, so there's going to be a limitation there. So since we're pointing downward, and when we read range, we go always from the low to high. We're actually coming all the way from -infinity, but then we go up to a certain point and stop because we have a maximum. If we have a minimum, we'd start from a number and then go all the way to +infinity. So that would be actually at +2 is where we stop, and we do include it. Okay, and that's it. These are the 5 things that I got just from having this vertex form. Okay, so we'll do 11. Alright, I'm going to try to make these videos relatively short, kind of the 7-8 minute range. Alright, so now we've got h of x, and that guy is going to be 3 in front. Okay, and so believe it or not, that 3 is not going to change too much this information. It's just not. But we're going to graph it like we should, but we are not going. That 3 is not going to have much effect on what's going on with these labels. So I'm going over 4, and I'm going to go down 3, so I'm right there. And if I'm going to go 3, that means I'm going to move over 1, up 3, over 1, up 3. All right, so this guy is kind of squeezed at the axis of symmetry, closer to it. Okay, now from there I can actually answer the rest of these questions. I know the vertex, it's going to be +4, but it's going to drop 3, so that's -3. I know that this is a min because it is the bottom of a hill, basically, so this is a minimum value. And then axis of symmetry is just the x equals. My phone is actually playing it right now. If you turn on the blue speaker. Alright, so x equals 4. Then we've got the domain. Again, all real numbers because the arrows. Okay, so we can just do that. Or again, just write that. That's not a problem. And then for the range again will always be a particular number to infinity or -infinity to a particular number. That's just how it works. If you start all the way from the lowest value, the min here, you're going to have -3, and then he will shoot up to infinity. So notice that this 3 actually had no effect on these attributes of the quadratic function. But it's very important for the graph, but it's not important to get these major attributes. Okay? Alright, and we'll do number 12 and 13 in a separate video.